Welcome to this video. We will solve the following problem. A car moves on a roundabout, so that's circular motion, and this roundabout, this circle, has radius r. So here on the figure, this is r, that's the radius. Now the car is moving with constant speed v1. Now remember, when you have circular motion with constant speed, that's what we call uniform circular motion. Okay, so the car is moving with this constant speed v1 for one lap, just one round. And then the car continues a second lap, but with a different speed, which is also constant, but we call it v2. So we have two laps, and there is a speed for each lap. The speed in each lap is constant, but they are different, v1 and v2. And now the question is, find the average speed for the two laps combined. So if we think about the two laps together, the question is, what is the average speed for the whole trip? Now let's try to answer this question and to understand each step. So let's say this is the car. Now the car is moving on the circle, so that's circular motion. And we agreed that because in the first lap the speed is constant, so that's what we call uniform circular motion. Now, if the speed is constant, let's just now discuss the first lap, okay? So let's just, now we're gonna talk about the first round. Now, V1 is constant. And if I ask you now, what is the average speed during the first lap only? Well, if the speed is constant during the first lap, so the average speed should be the same because the speed is not changing, it's constant. So that means the average speed is also V1. If we ask about the second lap, then the average speed for the second lap will be V2. Okay, let's just stick with the first lap for now. So we know the average speed, V1. Now, how do you find average speed in general? Average speed, the way we define it is, it's equal the distance that the object traveled during divided by the time of that travel. So distance over time. Now, during the first lap, the distance is just the circumference, which is 2 pi times the radius, r. So that's the distance. We already know that, even though we don't have the numbers, but at least we know that r is given in the question. Divided by time of the first lap. Now, we don't know that. So we're going to just keep it as unknown, and let's call it T1. So that's the time it takes the car to travel the first lap. And the answer will be V1, which is the average speed, which is the same as the speed, because it's constant. So we got this relationship. And from this, we can also write it in a different way. Let's just take time to the other side. So T1, the time, T1 will be 2 pi r divided by speed number 1. So we got this relation, which relates the time of travel to the distance, the circumference, and the speed. So now we are done with the first lap. Now let's talk about the second lap. Well, we're gonna repeat the same thing. Now the average speed during the second lap is V2, which is exactly the speed during the second lap. And because the speed is constant, so the average should be the same. So that should also be 2 pi r, which is the same distance, circumference. However, time will be different now. It will be T2. So the second lap will take time T2. From that, we know that time 2 will be 2 pi r divided by speed number 2. Okay, so now after we analyze these 2 points, now we come to our question. The question says, if we think about the two laps together, so the total distance will be twice the circumference. The question is, what is the average speed for both laps together? Now, some students may think that because the average speed was v1 for the first lap and v2 for the second lap, then the average speed is v1 plus v2 over 2. So just add the two speeds and divide by 2. I would expect many students to think that way. Unfortunately, this is not true. You cannot conclude that the average speed is v1 plus v2 divided by 2. The reason is, imagine that the car is moving in the first lap with a small speed. So v1 is small. Now that means it will take a long time to finish the first lap. Now, if the speed v2 now is bigger, so that means it will take shorter time to travel the second lap. So you can see that during the travel, the car is taking long time for the first round and little time for the second lap. So as a whole, the average speed is not just adding the two speeds dividing by 2. The way we should solve this problem is by taking the definition of its average speed, which is the total distance. Now it's going to be twice 2 pi r. So that's twice the distance of the circumference divided by the total time that will take to travel both laps. So that's going to be t1 plus t2. This is the definition of average speed. This is how we find average speed. We need the total distance and we need the total time. Now, let's continue and do the math and to find the answer. But that's the physical meaning, and that's how we apply the equation to calculate average speed. So now let's see. This should equal 4 pi r. That's twice the circumference, dividing by, now we're adding the 2 times, t1 plus t2. And you can see now t1 plus t2 are given here. So I'm going to substitute. So I get 2 pi r over v1, speed number 1, plus 2 pi r divided by speed number 2. Now, just with little math to simplify this, you can see that pi r will cancel from all sides. There's also factor 2 which will cancel, so I'm gonna be left with 2 up. And now, by simplifying the math, you can see that the answer will be, I leave this to you, very simple math to do. It will be divided by v1 plus v2. So that's the answer. This is the average speed for the two laps together. And you can see the answer is not v1 plus v2 divided by 2. So now we already finished solving the problem. Let me just look at the answer again. Try to think. What happened if one of the speeds, v1, is so small that it's much smaller than v2. So that means v1 is very, very small compared to speed number 2. Speed number 2 is very large. So of course, physically that means, because v1 is so small, the speed, so that means it will take a very long time to finish the first lap. However, it will take a very short time to finish lap 2. So now the question is, what do you think the average speed will be in this limit? Now you can check. If v1 is so small compared to v2, so when you add them in the denominator, when you add something very, very small to something large, so the answer will be almost v2. You can ignore v1 in that case. So I got almost v2 in the denominator, and then this will cancel v2 in the numerator, and the answer will be, the average speed will be about approximately 2. I will get v1. So that's the answer. So the answer, if V1 is very, very small, then the average speed for both laps will be approximately twice V1. And the reason is because the car is traveling twice the distance of the first lap, that's twice the circumference. However, the time for doing that almost will be the time to finish one lap, because the second lap is going to take very short time that you can ignore. So we got twice the distance divided by T1, and that will give us twice V1. So it's only in this limit that when V1 is much smaller than V2, the average speed will be almost twice V1. What's going to happen if the two speeds are equal? Well, you should expect now to get something familiar. So the answer will be the average speed, in this case, will be, now you can check, if V1 and V2 are equal, so the denominator will be twice one of them, 2V1 let's say. Now some cancellation will happen with the two up and one of the speeds, and then you will get just any one of them, V1 or V2, they are equal. And that makes sense, because if the car is just keeping moving with the same speed both laps, so the average speed should be just the speed itself, V1 or V2, they are just equal. So that's the answer for the question. I would add another comment for students. Now, just to remember that there is something else in physics that we call the average velocity. Now, this is something different from average speed. So, what is average velocity? Now, average velocity is different from average speed because it's a vector. Average velocity is a vector. And it's defined through the displacement over time. Now, when the car finishes a lap, it means it goes back to the same location. So displacement will be 0. So when the answer will be 0, because the car is just going back to the same location it started. And so the answer will be 0. So that's the difference, important difference between average speed and average velocity. Hope this video was clear and easy. See you in a different video. Thank you.